Okay, the lesson starts from here. We want to recap again. Recap. We were on word example 34. We want to recap how a question such as question 34 can be achieved. One way to go about it is we can do this question slowly. How do we do it slowly? We are given the acceleration. Right, we're given the acceleration. We want to be able to find from the acceleration, right? From the acceleration, we want to be able to find the velocity expression. If this is my acceleration, we all know that by integrating the acceleration, I get the velocity. And then because you are given a condition in part A, right? You are given that the velocity is 0 when time t is 0. That implies that my c, the constant, is 0. Therefore, my vt becomes just 3t squared over 2 minus t cubed over 3 plus 0. Now the question wants you to find the velocity at t equals to 5, which means you are asked to find this number. And you simply plug it in. So this is one approach you can take for part A, which is what you had probably done in a lower year, right? In this example, it shows you two ways. One way is the way we have just discussed. The other way is to make use of the first theorem. In the first theorem, you want to realize that this is already a known statement. From this known statement, right? From this known statement, we can then actually work out the velocity at t equals to 5 immediately without having to first find the constant c. And you find that in this question, it is repeated in part B and later on in part C. So it's like doing the same thing 3 times. You know what I mean? And you have a choice whether you use the so-called method 1 or the method 2. You have a choice. So moving on, let's look at another example. This time round, it is actually an example that we got to fill in together. Alright. So in this case, we are asked to find the displacement change of P. Displacement change, okay, if I were to denote displacement as, okay, so this acceleration, right, this acceleration, and typically this is a notation for velocity. And for acceleration, sometimes people use the letter S, and sometimes people use the letter X. Okay, in this case, let's use X, okay? Let's use X. So in this question, it is actually asking you for the change of the displacement, right? Between t equals 2 and 4. So in this question, they are asking you for the change in the displacement between 4 or between 2 and 4. So they're basically asking for this. Using the first theorem, given that velocity is the differentiation of displacement, this thing can be written as 2 to 4 the velocity. And that naturally leads me to try to work out the velocity, right? We need the velocity expression. How do you find the velocity expression? Let's do it here. We know the acceleration and we know the velocity at time t equals to 0. So v0 is equals to 3. Okay. To find the vt, right? Okay, we can do it like this, no? Okay, I'm gonna write something, and I hope that people objects.
Objection.
What is the issue here?
You wrote it. You're using the variable as well.
What the hell?
This is not allowed, you know. This is not allowed. So what should I do? Behind, I heard something from Brandon, right? Brandon? Okay, not Brandon. So Ivan, what should I have done? What should be done?
What do you even say? I didn't say anything.
You didn't say anything,
It's Jethro.
Jethro.
Why are you targeting me?
You said it.
Yeah, you're very careful with the notation, you know. If you intend to do it like this, you must make sure that the variable names are written carefully. I have decided to use the dummy variable x greater than t to avoid the confusion on the use of variable. So from here, right, I can actually perform my integration. Zero to t plus 3, and then this gives me minus et plus 2t plus 4. And so now I can continue my quest for the change in displacement. I am trying to write this thing carefully, and I think that maybe I should save up this file and just push it out to the WhatsApp, you know, just in case you miss copying, right? I'm going to, from henceforth, be as neat as I can. And then this gives me minus et plus t squared plus 4t, then 2 to 4. So this gives me e squared minus e4, 1632 minus 12, I think it's 20. Check for me now. 32 minus 12. Yes, Chris, speak. Why is it 4, right? Okay, I count to 5 again. Yes, very. I make mistakes. Should be how much? Which one? Oh. Here, right?
Yeah.
Oops, my bad. Oh, they're very wrong. Sorry. Thank you. I missed a minus here. Yeah.
Wait, why would you do something like that? Like on the right side?
On the right side, is it?
Yeah, what would you do?
No. Okay, so you're asking me here, right? Here. Is it?
Yeah.
Okay, if you do not want to do it this way, you can integrate your acceleration slowly as vt equals to minus e minus t plus 2t plus c, and then you find a c slowly.
So, huh? I still don't understand the text. Yeah, I don't understand why there's X and T in the same.
Oh, this one is it?
Yeah. Yeah, I get that, but why?
Because
Because you're subbing in T. You cannot sub in T into T. It has to be X so that you can sub in X equals T.
Huh? No, wait, but Mr. Lim, why would you like?
okay, let me say back here okay, 大家agree stay calm. This T is actually so-called a fixed unknown, and this is actually a variable. If I were to put this as dt instead of dx, there's a confusion already. Dt as a variable conflicts with the use of this t here as a fixed unknown.
Then Mr. Lim, can you just like indefinite integral?
Yeah, you can do this like what you're trying to suggest to me. You can do them first, and then find the c
I don't feel.
slowly. What's the big deal, right? What's the big deal, right?
No, wait, no. I asked what's the point.
Okay, I understand. Therefore, that so to let me ask Chen Hui, do you feel troubled when people write this? You should, you should. Okay, why is it so long? Because
Yeah, because we sub in T. It just becomes T. T equals T.
T equals T.
The T is two different things there.
That's a little controlling.
T equals like T1 or something.
There's two different things.
Just use a different word. I mean, I get why a T1. No, I get why you would use.
okay, in the short to make it short for you, Chen Hui, you cannot have this thing, sure, and this thing the same name. Cannot.
You think the same data for two different things?
Because as a dx, right, x is a variable. As a limit of a integral, it's like a fixed unknown.
So show me. It's just like you use 4 to 0, there's like you sub in X equals 4.
It's more important than the X, that the T is the variable T.
Okay. Maybe for the time being, you want to remember that you cannot do this. You gotta do this one. So remember as a rule of thumb for a moment. Because as a dx, right, the x is actually a variable. You are integrating with respect to x. And the limits, right, is supposed to be some fixed point for that integral.
I feel like, right, it's not instead of changing the variable, I change the
You put T1, is it? Sure. If you put it as T1, then later on, eventually you're going to have VT1. You want that? Or you want VT? You want the final output to be the final working, right? Do you want the final working to be VT? Or do you want to be VT1? You know what I mean?
What's that one? You know that the fourth.
Go off the board.
The X variable is anything.
Yes. I made mistake, is it? Yeah, there should be a minus and minus. There's no more minus. Minus on the power. Okay, thank you for pointing out. So I made another mistake. Can you all correct the mistake? Please correct the mistake. Yeah, so embarrassing. Okay, so check. Christopher, check that I'm now correct.
Yeah, I got it.
Thank you. So I hope Chen Hui and Aditi will understand that we cannot have the left You must do the right.
No, I get why you cannot have the gem. But why do you need to?
Do it that way, right?
Yeah.
Nothing stops you from going back to the good old days. Nothing stops you. Just that it looks more elegant to try to embrace the first theorem and use it right away. Aditi, don't you think that this way of doing things is very elegant?
Wait, I don't. Hang on. I need to pass it.
Yep, sure. Oh, okay. Now I get the point. She really doesn't like me to use X because it confuses her. Let's change. Let's change to U. Is it okay better now? Ah, okay. W again. W is safe. Ah.
No. We are not doing physics here. No.
Okay.
This isn't physics.
Is M okay?
And this mess.
It's alright lah. It's alright. Okay. M.
Just use Y. Y doesn't mean anything in physics.
Y now. Okay. Ryan is proposing that we use Y instead.
Because Y doesn't mean any we are variable in physics for people to argue.
Okay. Let's settle for M lah. Let's settle for M.
Whatever lah.
Okay.
Just use a variable that doesn't confuse yourself. Can already.
Let's do another question. Okay. Do you remember? Do you remember the trapezium rule? Okay. In fact, all of us have memorized the formula for trapezium rule. Just that you get very careful, no? The formula that you have memorized only works if the width are all the same. When the width,
Intervals are equal.
what happened? You didn't finish the story. I'm trying to say that you didn't finish the story. Stop halfway. Howard, what's the story about? Share the story.
I was asking him about
Okay. So, Ashad, trapezium rule. Do you remember? Do you remember the trapezium rule?
Yeah.
Okay.
I never bothered memorizing the formula.
You do it on the spot.
Yeah, I do it.
So for this case, right? For this case, if you want to actually evaluate the 0 to 6, integrating from 0 to 6 using the trapezium rule, 0 to 6 using the trapezium rule, this thing is approximately, okay, Ashad,
Yeah.
your show. Half of what?
Plus half times 1 times 1 plus half times 1 plus 13 times
Right. Okay, now to explain the meaning, right? You want to remember that the integration of acceleration is the so this represents the change in the AP exam. You're very careful. No? If you stop here, you get 0. No?
From time 0 to time 6.
Yeah. You must be very specific. In fact, sometimes they will ask you to state the unit. Okay. AP exam is very tricky about little details like the unit. the correct description, the information they must give to the letter. No? And people lose marks because of these things, no? Not because they don't know math, they know enough math. Then the next part is, given that this thing concave up on 0 to 6, concave up means like this, no? Means like that. They are saying that the AT graph looks like this. If a graph concave up right now, what do you think about this approximation? Part A, answer. If a graph concave up and you draw the trapezium, you can see very clearly that if a graph concave up, the trapezium actually what? Overestimate. I'm not sure whether overestimate is one single word or hyphenated here.
Overestimated is a single word.
Single word, thank you.
It is literally there in the question.
No, I'm not sure whether or not it is right. I'm not sure whether,
The question is wrong.
No. Something grammar in the math notes, in the math write-up, right, may not be exactly,
Because
Yeah, because math.
Yeah.
I want to make this remark, no? In AP exam, such a question does appear. In such a question, they will just say, does your method over or underestimate? They don't even tell you is concave up or down. For such a question, you have to carry out an investigation to check if it concave up or down. And after that, right, you will say it overestimates because the graph concave up. Full stop. Why I want to stress on this, because I've seen a lot of solutions that students produce in test exams, is that they're not so sure, whether or not just saying that it overestimates is good enough to say is due to that the graph concave up isn't good enough. So they start drawing graph, and start to draw on the graph a lot of things to say it more. They're good, they're trying to give more information to make their ground of the conclusion solid. But actually, all that they need for such question is for you to just simply establish that it concave up or down, and say since it concave up, therefore it will estimate. Full stop. Don't have to say too much, You know what I mean? Because it's typically maybe 1 mark only, Right? So because I'm just afraid that you start to draw a lot of diagrams, try to explain a lot of things which is not really required. So to a learned person, right, if you know the graph concave up and therefore overestimate, they know that you know. Good enough. Okay.
You don't have to say
Supposedly, if the question asks, does the approximate value over or underestimate the actual one? They just ask like that. That means they don't tell you whether or not the graph concave up down. So you do some calculation to show that it concave up or concave down. That make a conclusion straight. No, you draw too many things.
But you said the ratio concave.
Yes. Okay, for the case of part C, many people see that just because the velocity is negative, you jump to the conclusion that it's actually slowing down. It's not like that, I want you to know that it is slowing down. If it's slowing down, if the velocity and the acceleration are in opposite direction. Okay, if the product is negative, it means slowing down. So for this question, to check whether it is slowing down or speeding up, all you needed to do is to calculate the product of the velocity and the acceleration at t equals to 0. So since a0 times v0 is equals to, let's check again. What is A0? A0 is 7. And V0 is minus 2, which is negative. This implies that it is slowing down. Okay, this is how you should check. Many people leave to think that you judge this thing based on just velocity. It's not, because if the velocity is negative and the acceleration is negative, right? It only means that it is accelerating in the negative direction. That means it's speeding up actually. Okay. So here shows you some diagrams. Moving on, we are shown a diagram. One is a VT graph and one is a absolute V against T graph. The left hand graph tells you something about velocity, and we already know by now that if you were to integrate from T1 to T2, if you were to integrate like this, if you were to integrate T1 to T2 of your VT graph here, what you will get is actually the change in displacement over the duration from T1 to T2. You do not get the distance traveled, you do not. You do not get the distance traveled, you get a change in displacement. Yeah, change in displacement. In the second diagram, if you add up the area A1 and A2, in this diagram, right? In this diagram, I want you to note that A2 being above the axis, right, is positive. This will give you what? The distance traveled. In a typical exam, right? In a typical exam like this, right? In a typical exam like this, they will typically give you a diagram of V against T. They will also tell you the function Vt. And they have a point on the diagram that shows you that Vt is 0 somewhere. And therefore there's a positive and a negative area. And then using this diagram, they ask you to find the distance. By now, I am sure you know that to find the distance, right? If you ever have to find a distance from a VT graph, you can simply find the distance by this. Okay. If calculator is allowed, if calculator is allowed, you can just find the distance right away like this now. Which means, class, I'm trying to highlight to you that you don't really have to find the intermediate point C. You don't have to. If calculator is allowed, you can find the distance right away. Because if you know this method, it becomes very easy. If you do not know, you will actually go about finding the value C first, and then start to integrate from T1 to C. And then T2 to C, separately, Zheng Hong, are you hungry or something? Are you hungry? You can eat, you can eat. Okay, let's try this. For this question, right? If I ask to find the average speed, it is actually the total distance divided by the time interval. How to find the total distance? But you can do it like this, or you can do it like this, For those who have drawn the graph, at least in your mind, you could have done it like this. Plus integrating from 5 to 6 t plus 3 and t minus 5 dt. Of course, okay. You can draw the VT graph to see, you know. If you were to do a sketch of the VT graph, just over here, the VT graph looks like this, you know. Where this is minus 3 and this is 5. Five to 6. The first one is the negative here. Let me make it bigger. Is it visible now?
Can you see the graph again?
Sure.
Oh yeah, no.
It's very nice to go digital, no? I can enlarge my handwriting right away. Yeah. Yeah. And then add all colors to our lessons, you know.
More joy.
Right. Min, are you troubled with something? Good. To find the average velocity over the time interval, the average velocity is equals to integration from 0 to 6. Ivan, are you jotting down your notes, Ivan? Okay, I can take a look what Ivan's doing now. Ivan's very fast. The point is close, I knew it. Okay. Ivan is doing mentally. Actually, a lot of you could have just come to the front here and do the same thing as I'm doing it. Actually, I'm sure all of you are quite capable, right? All of you are capable of just coming here and do the same question because you're well trained, I guess. Well trained. The topic is too simple for you. That's why people like Ivan dozes off. You. That's not dozing off, no. That's having a good time. You know, sleep is like this. Sleep, you must sleep at a regular hour. That means every day 11 p.m. sleep, and every day you get up at 7 a.m. You must be regular, you know. If you sometimes sleep too early, sometimes sleep late, sometimes sleep more than what you need, it won't work anymore. Right, so you must regulate your sleep. Make sure you sleep at the same timing every day and get up at the same timing every day. The body works best if it is regular.
It works best in the school.
Even to do your business, the poop, pee, you must do it at a regular time, Then only you are healthy. If your body bowels are done erratically, that means may not be very good for you, So you must actually manage all these things,
This period, the body works when there's no more.
Okay, let's press on with this applications of indication to finding area. And I check out when I did with O4, they all know how to find area and they all know how to find volume. And because of this knowledge that you have, instead of teaching you, let me just test you. And I'd like to hear from the class, if you have a graph that's like this. Okay, I'm drawing you a graph. This is the graph of y1, and my y2 is actually a horizontal line. This A and B. This is the shaded region. Class, is there anyone here who do not know how to find the area of the shaded region? Anyone here needs help?
Yes, I need like
Take a pencil and shake over the area, see how much pencil I can do.
Good one, Jethro. A nice idea. Yes. Sure. Why you formally address of today? You have a go. Now is it? Okay, all the best. Right. He's going for a scholarship interview. Okay, if I say this area is rotated about the x-axis, can you now form an idea in your head? What? Firstly, how will the object look like? A weird donut, that's right.
Yeah, weird donut.
And how to find the volume?
High degree is from A to B, y1 minus y2 squared.
Yay! Yeah, that thing.
If this thing is rotated about the line y2, it's no longer a donut. Okay, Chris, say.
And it really just becomes a solid shape.
Just tell me how to find this volume, Chris, say.
Yeah.
y1 minus y2, then that's floating squared. That's it.
Okay. If you have a graph that's like that, this is y1 and this is y2. And this time now, y2 is a vertical line. Lawrence, your hands is raised. Yeah, go to the toilet, wash your eyes. Go ahead. Yeah. Do you have eye drops, not? Is your eyes hurting? Okay, for this one,
Mr. Lim but if it's on the graph side, shouldn't the y1 and y2 be expressed as x1 and x2 instead?
Soon. Okay, Ryan is prepared to tell me how to find this area. Ryan, go. Okay, Ryan is trying to tell me this. And in this expression, you later on have to make x1 in terms of y and also x2 in terms of y. If you rotate this region about the y-axis, right and go.
I degree from A to B x1 square minus x2 square dy.
Brilliant! If you rotate about y2,
I integrate from A to B x1 minus x2 whole thing square dy.
right. Nice siren.
Doppler. Doppler.
In the night, in darkness, right, when you turn on the police blinker, it looks very nice actually. Yeah. I've done that before because I told before I was a policeman, an SS man, so we drive sometime near cemeteries in the night. So you turn on blinker, it looks very nice. Okay, with this, right, with this, I want to ask you this question, okay? Let's plunge into this question. Let's see if you know. The other class say they already know. Okay, this class. Find an area bounded by tangent inverse y to the power 4 and the y. So in this case, in this question, right? In this question, you're asked to find the area bounded by that thingy, and then this is actually the required area. Okay, how do we go about finding this area? Without looking at a solution, you have to form an idea in your mind, and then we will discuss. One way of finding the area, which is the easier way, is to integrate from 0 to pi over 4 x dy, and your x is, in this case, tangent y. And how do we integrate tangent y?
Wait, no, I lied.
Secant tangent?
So, it's negative log something cosine.
Okay, you know why? You know what?
Plus secant is a derivative.
How do we integrate tangent y, Chinmaya?
Then why is sine y over cosine y?
Integrating tangent y, what do you get?
Yes.
You're right, you're right, you're right, you're right,
Yes.
you're right.
Just yes.
Oh wait.
Right, so this is how you integrate tangent. You can find the same area using a harder way. Although you're not going to use it, but I'm just showing you that you can do this same area.
Integrates tangent inverse.
Wow.
You got share method.
Minus 0 to 1. You can do this other way.
Integrate tangent inverse, man. You got share method.
5 parts. 5 parts. Yep. So this question shows you both ways. After my class is okay, I'm going to end at 9:15 so that I can catch your reason and instruct to do the grade task. Okay, and then I will. Do we do it in the class or outside staff room? Raise? Huh? It's okay. So do you prefer here or outside staff room? Here. Okay. Sure. What is it? Sure. 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 We can do it there. Okay. Now you want to look at this example, and I'd like you to try on your own now. Don't look at the solution, Without looking at the solution, you want to give a shot at this. If you can do 29 A, B, C, and D, it means you will be able to do tutorial 3.3. So while you try, let me check this site for your completion of tutorial 3.
I did some of it.
Some only. Ryan, I am disappointed. I didn't expect this. Yutong, let me see.
Then you want to do this one.
You didn't do, Yutong. Out of the window.
What? Sorry.
Okay, Steven.
I tried.
It's a pause that counts, right?
Yeah.
Wow, you tried. Okay, you did the best among the three of you, right? You said the 51. Yeah, I see Eden's book. They quite eat some more, no? So you did on your own or you consulted the video at times? I hope the video is helpful. Okay, then at least you tried. Okay? Okay, your role model. The signature girl. He was lesson for 4 days, I think he was so bad. I don't know he was.
There is no bad.
One day too many.
What happened?
One day too
I was
many.
expecting to decide him as a role model for one more class. It's very hard.
In my defense, I had to revise for CT because my entire weekend was worse by negative attacks.
Yeah, you don't go to talk about foreign.
Even at 5 different systems at the same time.
Just 1 second.
Sketchy, best sketchy. Sure, I sketchy, best sketches. Okay, that's nice. But if this look at how the how a best leads you like this. And even follow the check execution. It's a video. I saw the video. The tiny solution method. Okay, class. Now, curriculum time-wise, we have lost time 11 minutes because of holiday, because of HBL. You must take HBL, like lesson time though. You must do it diligently. So I go around to check. The collective effort is maybe collectively maybe about 30%, 30%. So by Monday when I see you, I think at tonight you probably have other thing to do. But by Monday I see you. When I go around the class, I hope to see that everybody is filled in or done 3.2 like that.
CTs, it's not like this, are the score of CTs.
Not what the CT. Not in the mood yet lah.
If math CT is going to be next week, we do it after math CT. Because this is like.
Okay. Reason this piece of work should be done on Monday and Tuesday actually.
But Monday,
Okay.
we're revising for like the and the
Yeah. So therefore the HBL actually doesn't work. No. The HBL actually actually make you want to spend the time studying for tests. So but if you're not for HBL, if you have been in class, right, then I will have actually move you to do it, and then you have done at least quite a fair bit over Monday and Tuesday, right?
Then plus in class, then if people have any questions, then they can ask like
true, on the spot.
try to.
Okay, I'll note that. So I maybe this way I leave you to juggle your time. Rayson prefer to do it after the common test. Sure, I'm okay. Right. So if you think that helps you to learn better, sure. But if you can actually catch up and finish up the tutorial, that is very very good, I know. Right. Okay. Because Rayson has a good reason because he was on holidays. Sorry, he was on MC. Actually, COVID is not that bad, like, COVID is still quite, can still move around. Yeah. Bad for your reason. My daughter had it twice, I had it once, and both occasions we survived.
Hey, you know, good job, man.
Okay, example 39. How define okay, this one is very interesting, where each cross section is a square. Now, even though you might already know this, I want to actually go through a bit with you. The way to do this kind of question efficiently. I was told that you learned it from Mr. Teo last year, is it? Your math teacher. And you all learned it well, I was told. The moment it is perpendicular to the x-axis, right, the way to remember is, for part A, right? The way to remember is straight dx. So bear in mind, the way to remember the steps. When it is perpendicular about the x-axis, it is dx. In this case, x will run from 0 to pi. And because the area is made up of squares whose length or cross section are perpendicular to x-axis, it means this. No, it means if I draw a line here, I'm going to the board and tell you that the square is formed like this. From here, right? From here. And you repeat this for every vertical line from left to right. Once more, for a vertical line, you produce a square. Next line.
Actually, can't see it.
It comes out of the box. It comes out of the screen.
Just hear him do the.
Can you see the? Just hear him do that. It comes out. Yeah. So you got a lot of these cross sections together. It forms a solid. And to find the volume of the solid, I know that you know, but I want you to tell me why. Roughly, right? Roughly again. Roughly, this y square gives you the area of the square. This y square, because this y times y is the area of the square. This dx is something like the delta x. The area of the square times the small thickness gives you the small volume. And now this integration means you sum up all the small volume to give you the entire volume. Is there a pillow for her? You put a bag, put a soft bag or something, you have a bag, so that she can lie down comfortably. Okay, then this becomes 0 to pi. Okay. And Ting Hui, if you can do this integration, you can just continue going back to sleep. Ting Hui, do you know how to do this integration? You need a half. You need a half.
1 minus.
Right, 1 minus what? 1 minus. Right. Okay, this is how you do part A, not part A. In the case of part B, right? Part B, you want to note, it is the moment it is perpendicular to the y-axis class. I want you to know that it has to be a dy. And y in this case, it runs from 0 to 1. And it says that it is an equilateral triangle. So what happened is, so you draw a line like this. This line is now extended to become an equilateral triangle. So you can imagine from this line,
And the triangle is
you produce a triangle. All the triangles are protruding out this way, protruding out this way. Another triangle that protrudes out this way. So together, you form a solid.
But student, you can differentiate integrate with respect to x. But technically,
Yeah, I'm hearing you. It's good.
sine pi minus x minus sine x is your base. Then your height is sine pi minus x.
Sine of pi minus x. And then
So sine pi minus x minus sine x is your base.
I write.
Then your height is just that thing, and then you that's sine per.
Oh, is it the funny?
Yeah, it is. Your height is whatever length you want, and then huh? Wait.
Wait, hang on. So you say from this line, how do you go about it? Yeah, right. You say this x, this is this x, and then what else? This is pi minus x, and what else do you do?
And then your height is your base percent of e, right? Yeah, it is because your side is yeah, it is. Right?
And then
Then you can find your half.
just say find the area in terms of x,
Yeah, that's why.
and then
I
no, you cannot because if you got an area in terms of x, right, so-called in terms of x, right, you need to times so-called by the delta y to get the volume. And then now if this is dy, if this is in x, right, you can't integrate. You can't integrate with respect to y when the inside is x.
no, as in I integrated with respect to x, with the inside being x.
Then change the dx just like
Yeah, I
that.
changed that to my working is your
As I said just now, you got the expression of the area of the triangle in x, right? This area must have delta y to be the volume.
no, but I integrated with respect to x.
No, cannot. Because if you say you may expect the x means you're taking this area times the change in x. So the change in x means here, no? Here. Doesn't make sense. Geometrically, it doesn't make sense. You cannot take the area of triangle times the small change in x to give you the volume of the small.
No, because my small change in x.
Wait, take it offline. I'll correct this offline. But I'm telling you that there's something incorrect by what you say. Yeah, you can. Okay. Okay. So for this edge here, we want to find this number. What is this number? This number will be, okay, one number is sine inverse y. What is the other number? Over here.
Pi minus sine inverse y.
Pi minus,
Sine inverse y.
right, pi minus sine inverse y. So therefore, this length, right, is equals to what? Is equals to the one on the right minus the one on the left. So the length is actually, the length is going to be pi minus 2 sine inverse y, right? Just the length of one side of the triangle. Let me ask you again. If you know the length of one side of this triangle and to find the area of that triangle, how do you go about it? Is half AB
Science.
sine what? Sine 60. Okay. And now you can try part C and part D while the two boys will march up to try to do their great task. The two boys, not try to do. Can the two boys find a good spot up there? Right. Can the two gentlemen on your feet, left, left, right, left. Are the two boys moving on? It's Rod and company. It's Rod, right? It's Rod. All the best, huh? You got your writing instrument then? Pencil, no need. Yeah, if you're, one pen is enough. 等一下，来哈 ，wait.
Why?
How much does it cost?
It's a brand. Yep. Yes, it is. Yeah, right. There's error in the book. You're supposed to stay in class and do C and D, you know. C and D.